on the validation aspect. Remember we introduced the idea of verification versus validation? Validation is, did you build the right thing? Did you build the thing the customer wants? Verification is, did you build the thing right? Given that you know what you believe the customer wants, does it function the way that you design it to function? And the unit and functional testing that we're going to start talking about in today's section form a big part of that. So we're going to talk about an introduction to RSpec and unit tests. Before we do that, a little bit of computer science trivia. Here's a very famous person in computer science who says, debugging is twice as hard as writing the code in the first place. Therefore, if you write the code as cleverly as possible, you're by definition not smart enough to debug it. Anybody know who this famous person is in computer science? Anybody? This is a Turing Award winner. He is the co-inventor of a famous language whose name begins and ends with a letter C. So this is Brian Kernighan. He's a Turing Award winner, co-inventor of C. Here's a colleague of his, another bearded, somewhat older gentleman, saying testing can never demonstrate the blank of something, or the blank of errors in software, but only their blank. Anybody know what goes in these blanks from this famous quotation? You can never demonstrate the blank of errors, the absence of errors, only their presence. So here are two very distinguished, both Turing Award winners. Edgar Dykstra is the one on the right. He's considered the father of object-oriented programming. So these are two very smart people who have spent a lot of time writing code and thinking about code and stressing the importance of testing. Here's a third take on the importance of testing. Has anybody seen this logo? Debugging sucks, testing rocks. This logo is seen, anyone? Where specifically at Google? In the bathrooms at Google. That is correct. I hold Google in very high regard as a company that takes testing very seriously, and their testing culture is so pervasive that when you go into the restroom, if you're a gentleman, you'll see over the urinals. If you're a woman, you'll see inside the stall doors, and don't ask me how I know that second thing. There's like these little one-pagers called testing on the toilet, and it's designed to be some nifty trick about how to improve your testing that you can sort of read in the couple of minutes that it takes you while you're doing your personal business in the bathroom. So testing is so important that Google wants to make sure there's not a minute of your day where you don't at least have the opportunity to think about how to improve your testing. So how do we think about testing in software engineering today? The way we used to think about it is the developers would finish some code, they would maybe do a little bit of ad hoc testing on their own, and then they would, quote, toss it over the wall to QA, and some hapless people would manually interact with the software and say, oh, okay, that kind of seems to work. That's not at all how it's done today. In pretty much all modern software houses, testing is part of every iteration. So if you're the developer, you're testing your own code. There's a lot of automation in the tools and processes to help you do that. And there is typically still a testing group or a QA group, but more typically, instead of being the people who write the tests, they're the people who create and curate the tools and the infrastructure that help the developers do their own testing. A great many years ago, certainly by the standards of how old I am, there was a statistic you could hear that at Microsoft, there was a ratio of roughly one software tester or QA person per developer. And the idea was, look how important testing is, that we have as many people doing the testing as we do writing the code. And a couple of years ago, I asked a colleague at Google, can you say something about this ratio at Google? And he said, well, our organization really isn't set up exactly that way, but if you made me name a ratio, I would say it's about 10 to 1. And I said, oh, wow, 10 testers for every developer. That's intense. And he said, no, it's the other way around. We have about 10 developers for every testing person. My jaw dropped to the floor, right? But of course, I didn't realize that the testing person is not there to write tests for all those developers' code. The testing person is there to be the test engineer. They create the tools and infrastructure that make testing possible. So the message is that testing today, software quality in general, it's not a thing that one particular group or person owns. It's the result of the process, and the process is owned by everybody. So how does this fit with what we've been doing with BDD plus TDD? You've already seen that the idea behind BDD is you develop these high-level user stories, and we think of them as the features that you wish you had, because you develop them with the customer before you write the code. It's to help you guide what the customer wants to have happen. And then via Cucumber, you can turn those stories into runnable integration tests and acceptance tests. Now we're going to start talking about TDD, or test-driven development. Some people also call it test-first development. And the idea here is that it sort of picks up where Cucumber leaves off, right? Cucumber, you have these step definitions that will implement how the test runs on that feature. TDD says the way you write the code that is to be tested is that you first write unit or functional tests before the code itself, and as soon as those are passing, that's what allows you to fill in those step definitions and realize a step in your user story. So we're going to talk about this in terms of writing tests for the code you wish you had, just like Cucumber is writing stories for the features you wish you had. Here's how these things look when you put them together. Cucumber describes behavior. So we think of this as kind of an inside-out cycle where you start by writing a Cucumber step, and that step initially fails because there's nothing in your app that would make the test pass. And from there, we're going to use that step to drive the actual development of the code in the app that would make it pass. The way we do that is we sort of recursively do the same procedure, except now we're going to drop down a level and say, now we're at the level of individual classes, methods, new code that we have to write. We're going to start by writing tests one at a time for each of those methods, watching that test fail because we don't have any code yet that would pass it, and then writing just enough code to backfill so that the test passes. Once we've done that, and we've done that for enough methods that Cucumber scenario step now passes and turns green, then we go back and we start working on the next Cucumber step. So this is almost like a cookbook recipe for going step by step through your app, and piece by piece, you're driving the development of the code that's going to make the Cucumber scenarios pass. So you can think of Cucumber as, at the level of high-level behaviors, complete flows exercising a feature, whereas we'll see that RSpec is about testing individual modules, both at a very fine-grained level and at the level of maybe several methods or classes at once. So just reviewing where we are in the testing world, this is a flow that we've already done. We've used Cucumber, and behind Cucumber was Capybara to simulate a web browser. That communicated with an app that was running on the Rack app server through this test glue, and that was what allowed us to write Cucumber-level integration tests. Now we're going to do a very similar process, and we're going to use RSpec to write unit and functional tests. In particular, we're going to use not just the RSpec framework, which you already have actually been exposed to in the homeworks, but the RSpec Rails gem. And just as Capybara extends Cucumber, if you will, by giving it specific ways to stimulate a web browser and look at the kinds of things a web browser would produce, RSpec Rails extends RSpec so as to provide you some ways of expressing test conditions that would arise in a Rails app but might not necessarily arise in plain old Ruby code that is not a SaaS application. So that's what we're going to do. So before we do that, let's just make sure that we're all on the same page about Bdd and Tdd and their respective roles. So which of these statements are true regarding Bdd and Tdd? A, that requirements drive implementation. B, they can be used only in agile development. C, they embrace and deal with change. So which combination of these statements is true? Take a minute.